Hi, my name is Ung-hee Lee, and in this lecture, I'm going to talk about NMRFAM Sparky, which is an integrated multi-dimensional animal data analysis software that you will use the remaining lectures in this workshop most of the time. NMRFAM Sparky features visualization of multi-dimensional spectra. You can pick a peak and assign that peak and examine chemical shift, intensity, volume, and line width of that peak, and other functions provided by Sparky is overlaying multiple spectra to see the changes in the spectra. And then you can change the contour level and colors, and appearance of spectra could be adjusted fits to your interest. And you can extract scientific meanings by analyzing the data. And then for doing that, many automated approaches implemented inside of the Sparky over time. And you can make publishable figure representing your contours and labels in the spectra. Let me tell you about the brief history of Sparky. So Sparky itself actually developed at UCSF, initiated from TechCon's group. The Donald Neller developed the first version of Sparky since 1989, about 5-6 years, and then the Tom Record from the Tom Ferrin group in UCSF took over it and developed for 5 years, and then they ceased the development and then focused more on Chimera. So since that time, even though Sparky has been one of the most popular software packages among animal spectroscopists, that development has not been active. That was picked up by myself. I was a developer for my software tools, so I was developing integration to the Sparky since 2008, such as Pine Sparky plugin and Ponderosa plugins, and then I took over it officially from UCSF. So that was 2015, and we rebranded the name to NMRFAM Sparky. So you can just mention if you're using the older version UCSF Sparky, then if you're using our version, you can say NMRFAM Sparky. So there are many features developed on top of it, and then actively we update with the improved features, automations, visualizations, and new functionalities are being developed, and you can download available operating system versions, Windows, Linux, and Mac, from the URL shown below here. So we will go over how to start the Sparky software and basic operations and very simple data analysis such as assignment. And actually the backbone and sidechain assignment will be followed by this lecture. So most important part in this lecture is get to know how to operate the NMRFAM Sparky with the very basic visualization and controls and control levels and sort of things. So let's get started. First of all, you gotta know the Sparky home and subdirectory structure. So you can set the working directory that you wanna work your project in, and then associated files will be in the under that working directory as subdirectories such as project, save, spectra, and so on. So you can set the working directory by two-letter code, capital R and capital D, as you can see here. Or you can go to the menu item and NMRFAM and utilities, you will see set Sparky home. it will ask you where you want to set as your working directory. Once you set it and relaunch the software, you will see the generated directory names, project, save, spectra, and lists. Other subdirectories such as reference directory, ipine, psi, and so on, these directories will be automatically generated once you run the relevant functions in the Sparky. So automatically you will get these project, save, spectra, and list directory. And then projects files will have the file extension proj. By default, you can name it differently, but I highly recommend using these file extensions not to be confused. And then if you set the sequence file by two-letter code as Q, so those two-letter codes are the command that you will type in the Sparky software, and then it will launch the feature associated with that two-letter code. You will get to that. So just know that there are shortcuts, one-letter code or two-letter code, and then it will run the functions, or you can reach to that functions from menu items. So projects, save files, and spectra, we will get to that briefly later. And then lists, pig list files, so containing chemical shifts of each dimension and data heights or some other informative items upon your option enabling. So these are all text files, and they have some kind of structure and hierarchy. Okay, so let's start the Sparky software first. Then once you launch the software, it will ask you about the subdirectory should be in the default directory, because you haven't set the Sparky home yet. So the Sparky will consider your default directory as Sparky under your username. So for this VM, username is NMRFAM, so the default directory will be /home/NMRFAM and /Sparky. Then while this will be the first launching of the software, you don't have subdirectories automatically generated such as projects, save, and list. So it will ask you if you want to create. Well, for now you can create, or you can say I'm gonna create later. Does not really matter at this point. And I will demonstrate the generation of the directory, so I will say yes. So let's get to it. So I'm changing my workspace to show the Sparky demonstration and at the same time presentation here. So I put my presentation in the workspace 2, and then workspace 1 is my software demonstration. So I will start Sparky software by double clicking the icon in the desktop, and as you could see in the presentation, it will ask me if I would like to generate the subdirectories, and I will say yes. Then you will see some messages here and new features developed recently, and you will see the latest build of the software and when the software has been installed since. So that was April 9th. And as you can see, that the installation date is late, before that, so you can install if you the newer version if you want to. Okay, so if you go to home folder, from places and home folder and Sparky directory here, you can see that those directories that I mentioned here. So right now is 11:53 a.m. and then the generation of the directory is only a minute before this time, so you could see that these directories are freshly made by clicking yes in that question. Okay, and then we want to set our Sparky home for the first time, which will be home NMRFAM desktop spectral practice. And then we will close the program and restart the Sparky. So just follow me step by step. I went back to the main window of the Sparky here, NMRFAM, utilities, and there is a change Sparky home. So you can see that the function name changed Sparky home, and then there's a little two characters. So they are all two-letter code shortcuts. So instead of coming to this menu item, you can just type capital R, capital D instead. So let me just type here, capital R, capital D. Then that's the same thing that you could browse into from your menu item, NMRFAM and utility. So like it was instructed in the presentation, we will go to desktop, home NMRFAM desktop, and spectral practice. Don't go to the other subdirectory inside, just keep your place in this window in spectral practice and say OK. Then you will be noticed that Sparky home has been changed, and please restart the program. So we will close this. So like it was said, you close it and restart. Okay, if you go to desktop and spectral practice, so we already had these directories, so we were not bothered by the program if we would like to generate those directories because they were already there. Okay, so let's go back to the slide and see what we're gonna do. So we close and restart the program, and we'll go briefly over the file types and file structure of the Sparky. So let me go back to here. So there are directories, and then these directories are the thing that I showed in the previous slides. So projects, save, spectra, and lists. So first of all, the spectra are the very basic raw data. So raw data means it contains spectral information such as your sweep width and the intensities for each grid point, and nuclei names such as C13 and 15 and proton. You will see those information, but does not carry any information about analyzed information such as line width, peak position, and assignment, and so on. So spectra itself is a very limited information from the data you converted, either NMR pipe or top spin, usually for protein NMR. It only contains you can imagine that is pretty similar to the image. So it has X and Y, if that is 3D, Z, and those are the coordinates, and you have data height, which may be compatible to RGB values. and spectra will be analyzed by the Sparky, and those analyzed information such as assignment labels, peaks, and control level settings, they will be saved in each save file. So save file points those UCSF files, so such as UCSF here. So UCSF file contains raw data, save file contains all the metadata. So save file itself is for a single experiment, so you will have multiple experiment for one protein, and the project in this directory you will have PROJ that will point to multiple save files like this. Okay, now you understand the hierarchical order that is already described in this slide like this. So UCSF is actual spectrum. Sparky does not add it. It's just the raw data, but save file will contain the relevant data that you analyzed for that UCSF, and then project file will have multiple save files. So save UCSF, it's one-on-one. You have one UCSF, you will have one save. Probably you can save differently and have different analytic data in save file pointing to the same UCSF, but in general you will have one-on-one matching, and then you will have a project file that contains multiple save files. Okay, and besides project spectra that you will get to know about view settings. For one spectrum you can make multiple views, but usually you will have one. But in case you want to go further, you want to see different axis order, or if you just for any reason you want to have another view with the overlaid features, you want to have multiple views in that case. And spectrum will have multiple signals, then they are all objects, and then each peak can have label, and labels are two kinds: assignment, or just a user label that does not contain assignment. Only the assignment will be considered to be calculated for resonance assignment. And then as you can see here, you will have multiple assignment for the same resonance from different spectrum. So at the end of the day, in the resonance list, you will have assignment from average and average value and standard deviation in that resonance list. And then you can have different molecule and condition. So let's say you say, okay, this spectrum is from 25 degree, then this spectrum is from 40 degree, and this spectrum is from mutation. Then you can set these conditions separately, and then you can choose which molecule condition to see the resonances, and it will filter it out. Or you just undefine everything, then it will use everything. Okay, and you can set contour setting differently for each spectral view, and you will see your spectrum differently based on your contour setting. So these are all objects that you will be dealing with, and we will do hands-on on that. Then this is just the optional look and feel feature that you can change. So from this VM, unfortunately background color and foreground color will not be changed because of the problem with that Mate desktop. But if you install NMRFAM Sparky on your computer, you can play with the look and feel, and also there is a new locales feature that you can change English, Korean, Farsi, Hindi, and so on. So if you are interested in providing your own mother tongue language for Sparky, you can contact me and you can have your locale here. And font could be changed, and some other small visualization options are there related to the resonance panel and scale panel in the view window that you can play with in case you are interested in.